Hi, everybody. My name is Jordan. I'm one of the editors of the spec for JavaScript, and I'm here to talk about the lifecycle of a TC39 proposal. So I'm going to start by giving a brief overview of what TC39 is. The TC is for Technical Committee. It's part of a standards body named ECMA. Originally, it was the European Computer Manufacturers Association. ECMA has standards for a lot of things. I listed a few on the slides: JSON, OpenOffice, XML, Dart, C#. There's a number of others. JavaScript is probably the most widely used standard that they manage. Members of ECMA, there's a lot of them. All the browser makers that you might be familiar with, various companies with websites, I've listed a few up there, companies that make embedded systems like Intel, IBM, Audible, and a lot more. And these slides will all be like, there'll be a link at the end, so all the clickable links, if you're curious, you can click on them. Members, the way it works is that member companies or nonprofits send delegates. So these usually are employees, but don't have to be, especially in the case of nonprofits. And then also the committee can bring in invited experts to just kind of come in and contribute. We meet 6 times a year for 3 8-hour-long days. It's a lot of talking, a lot to listen to. There we go. So I also wanted to go over kind of a timeline, a history of TC39. As we may all know, in '95, Brendan Eich released JavaScript in Netscape. A year later, Netscape submitted the language to ECMA for standardization. The next year was ES1 and then ES2. In '99 was kind of the big one. That was when I believe that was when there was a lot of buy-in from like Internet Explorer in particular, which in '99 was a very important partner to have. And ES3 brought in some new additions like regular expressions and try-catch, and probably a number of other things that I've forgotten, but that we now kind of take for granted. So the next section I called the dark times from 2000 to 2008. So this was when the committee was trying to work on ECMAScript 4, which was based heavily on ActionScript 3. Alex kind of alluded to this earlier, mentioning that Swift is kind of JavaScripty. This is why. They intended ActionScript to kind of become the new version of JavaScript and have them be the same. It didn't really succeed. There was a lot of arguing and debating and contention. And I've asked some folks that were there at the time, and were told there were issues around really speculative designs that were untested. And also there was a belief that like kind of versioning or forking the language would actually work out. But a lot of the people that made browsers really highly disagreed with that. And today that still seems to be the prevailing belief that kind of versioning JavaScript would fail. So around 2008, the decision was made in ES4 and try again with something that was a little more iterative, a little more of a kind of additive change to the ES3 we all knew and loved. And so then in 2009, ES5 was released, and 2 years later, 5.1. I couldn't tell you the difference between ES5 and 5.1 without looking it up. But 5.1 is like really the JavaScript that everyone kind of expected was used to before ES6 came out. So depending on whether you're familiar with ES3 or 5.1, kind of depends on how long you've been in the web game. But at each various chunk in time, this was just JavaScript. This was the way it worked. So then, and I joined the committee in 2014 after pretty much all the ES6 decisions were made. And in 2015, ES6 was released. At this time also, they decided to start doing yearly releases, and they changed kind of the name of the specification. So it's kind of a weird thing to try and force a community of people to call something different that they're used to calling it. But the kind of decision was it is the 6th edition, but it's ES 2015. And that's kind of become the preferred nomenclature from then on, because it doesn't really make sense to use an arbitrary number when it's coming out every year. So everything after ES 2015 has been yearly editions, a brand new process. So the ES6 and earlier process was basically just a bunch of people in a room arguing until they all were roughly, in agreement that this is what should go in the language. And then they put it there. And then when they were done, they published a standard, and browsers looked at that and said, okay, we'll start building that. In practice, there are some issues with this, which I'll get to a little later. The updated process that we have, which I'll be describing in detail, is actually, I'm very excited about it. It's much easier to have like a week-long debate meeting when you have kind of these clear processes around things, and when, well, you know, as I'll get to later, one of the important changes is that nothing can now land in the language until it's already been shipped by, you know, at least somebody. So that means that nothing will land in the language now that is kind of speculative, that we just hope will work. Things will only land in the language when they're proven to work by some metrics. And then the last one is that we moved from a Word document on the editor's computer to GitHub, which is delightfully better to work in than trying to download someone's Word document and give feedback. It's also made the JavaScript spec and a living standard, which means that unless you're like a book author or something, you really don't care about the year anymore. If it's in master on GitHub, it's in the language. That's the end of it. And there's a number of folks on the committee who are very pleased with that as well. Progress more iterative and more smooth, and less about arbitrary, you know, standards, bureaucracy around what's published in what year. Okay, so now I'm going to talk about the whole process. Basically, there's a process document. That's the link to it. It describes all the stages, which include entrance criteria, so like what a proposal has to do in order to enter each stage. It talks about what each stage like signifies or means, so like what it means for something to be in an arbitrary stage, what sort of changes you might expect to a proposal during a stage, and then also what sort of implementations you might expect. There's stages are numbered 0 through 4, and I'll go through each of those numbers in turn. Also, proposals all have to have at least one champion. A champion is a delegate or an invited expert or more who are kind of committing to driving forward the proposal. They may not actually be the author of the proposal. There have been a number of proposals that were written by non-delegate or, you know, non-TC39 community members that just were kind of adopted by someone on TC39 to drive through. And so that's kind of, I think the thinking around that is that if you have someone who's committed to like putting their name on it, then they're really going to help push it through and commit to making the best language feature that they can. And then also I referred earlier to like a group of people in a room agreeing. TC39 operates on consensus. So although I think technically we could vote on things, we generally do not. And most of us consider if a vote happens, it's a failure, like a process failure. So consensus doesn't mean everyone in the room likes it. Doesn't mean everyone's stoked on it. It means that nobody in the room has objected. So what that also means is that everything that has entered the language, it only would have taken one person to block it for it to never proceed any further. So everything that's entered the language, that means that a group of really highly opinionated people with a lot of different priorities who represent many different cohorts of users have all been convinced not to block the progression of a feature. What I think useful benefit that has is that it means that it's highly unlikely that any kind of downsides haven't been at least brought up in an attempt to persuade someone throughout the life of a proposal. In my personal take on that is that actually means that minority opinions, meaning like edge cases or smaller user cohorts, they may not always get a feature that serves them best, but their voice and their use case will never be completely ignored. And I think that's really valuable. In a vote-based system, whoever's got the most votes just decides. And that's not really an internet I want to be in. So the source of truth then, it's technically like what the committee has decided, which is represented in the notes that I've linked to. But really we have this repo, the proposals repo. That's the best place to look to get all of the current proposals and what stage they're at, and to get a link to each of the proposals repo, and where you can go talk about it and read up on it. So the first stage, stage 0, I call this the I have a crazy idea stage. Technically, there's nothing required to be in here, but unless we want to put every crazy idea on the internet on the stage 0 list, we've applied the kind of in practice and convention rule of it has to have a champion and it has to like be on the agenda and be added to the list by that person. So it has to be kind of a real thing that the committee is going to talk about. And there's currently 21 proposals on this list. So the next stage is stage 1. And I joke that this is also the, maybe this idea isn't so crazy stage, but more concretely, it's that the committee has agreed, this is in the process document, the committee has agreed that we want to spend more time thinking and talking about this problem. In other words, like, it's okay if you come back and fill our time, if it's stage 1. So primarily the proposals identified a problem, something that needs solving. It ideally has a suggested solution, like this is how we think we want to solve it. It has to have at least one champion. It kind of needs to have a good grasp of the landscape. So this means, like, what are the pros and cons of various solutions? What are the possible reasons why it's a bad idea? What are the reasons why it's really a good idea? What's prior art? So, like, what do other languages do? What do other JavaScript libraries do? How have other people tried to approach solving this problem? And it often takes a lot of effort to progress from here. You have to kind of have really done a lot of homework and research and documentation to be able to make a really compelling, persuasive case to a room full of pedants that this is the correct direction to go. And I think that's a good and appropriate amount of friction. There's currently 48 proposals that are stage 1. Some examples, I had one called error.isError, like array.isArray. Never made it to stage 1. The committee wasn't really interested in talking about, robustly brand checking an error across realms. Like, from another iframe or something. They wanted an entirely different approach to that to that use case, and so that ended up being a withdrawn or rejected proposal. But then there's a few others on there: promise.try, do expressions, pipeline is the one I'm personally excited about. Where instead of kind of nesting functions, from inside to out, you would do them left to right. And then first-class protocols. So, like, we all have. Stringifiable is something with a two-string method, and a promise protocol is thenable. It has a then function. And the iterator protocol that you do with for of or something, or the array spread. So please feel free to take a look at the list. There's some fun stuff in there. And now we move on to stage 2, which is where, as a group, we kind of think this is the best solution to the problem. You have to have initial spec text with major semantics addressed. I put that in quotes because if there's any chance we can debate about the meaning of a word, we're gonna. And there is sometimes debate about major. But generally that means, like, what syntax it uses, what its behavior is going to be, maybe the final name for, like, the name for a global or for a method is not set in stone, but we've got one we want, things like that. It signifies an expectation, but not a guarantee that the feature's eventually going to make it into the language. And I've put that because, as I've referenced farther down the slide, there are a lot of proposals that do stall or die in stage 2. So, for example, object.observe was shipped in Chrome for years, and then they removed it and withdrew the proposal. And there was easy consensus for that to happen. So I'll mention some other examples in a minute. Stage 2 is also when we hope that polyfills and transpilers like Babel or TypeScript will kind of test implementations, but hopefully not in production. I've mentioned that twice on the slide on purpose. Because things can change a lot in stage 2, including go away entirely, I really strongly recommend that you do not use anything in stage 2 or below in your production site, because you are risking a lot of code churn when things inevitably change. There's currently 17 proposals in stage 2. Some examples are decorators. It's on its 4th iteration, I believe, and Angular and TypeScript are relying on its 2nd. So that's an example of, resting on a feature a little early. There's something simple like throw expressions. The one I'm really excited about is temporal. So all the ways that date is broken in JavaScript, temporal will not be. It's actually, like, championed by some of the people that maintain Moment.js, and it's taking a lot of inspiration from Joda time, which, even though it's from Java, it's actually like a really well-designed date and time system, and it handles a lot of use cases. I didn't actually mean to throw that shade there, but it's hard for me not to. But then some other proposals that recently gained stage 2 that I'm also excited about are optional chaining, so like A question dot B, and nullish coalescing, and that's like A question B. And these deal with when you have something that might be null or undefined or not, and if you try and dive into something that's null or undefined, like with a dot or a bracket, it usually throws. So this kind of is a way for you to elegantly step around that. So now we come to stage 3. So this is when it's time for browsers and engines to try it out. Ideally, browsers do ship here in stage 3, and ideally not behind a flag, just ship it directly to the web. The only kinds of changes that are really expected in stage 3 are the sort of feedback we'd expect to only get if you're implementing it natively, or if it's being used at scale. So theoretically, before stage 3, all the kind of design issues have been brought up and addressed somehow. And I kind of alluded to this earlier. There's occasionally with certain proposals, there's a lot of feedback brought up within stage 3 that is not new information. It's just that these people have newly discovered the proposal and want to relitigate decisions we've already made earlier. And that's kind of this stage is also for user feedback, but that's kind of a tricky place for us to be as a committee who wants to please and serve a large community. But it does happen. So there's currently 12 proposals in the list. One of them is class fields, which is shipped in Chrome and I think Firefox, and on the way for a few others. Typically, Chrome and Firefox are the browsers that ship proposals early. Safari and historically Edge have kind of much slower release cycles, so they tend to wait until proposals are stage 4, just or almost stage 4, because they don't want to ship something and then have to wait a year to take it back out or change it. Some other stage 3 proposals are global this, so it's a portable way to access the global object, and numeric separators like 1_000, things like that. And then the last stage is stage 4. So this is when it's official. You have to have an editor-approved pull request to the main specification, meaning like the spec text is ready to go. You have to have merged tests with passing implementations into test 262. So this is our kind of official conformance suite. Over the last few years, the browsers have all been contributing their own individual tests to this main suite, and it's helped uncover a lot of bugs. Like there's a lot of bugs that Firefox fixed that Chrome didn't know about, and Chrome fixed that Firefox didn't know about, and so they've been able to kind of pool their efforts there. And the most debated part of the process, if you look at the process document, it says it requires significant in-the-field experience with shipping implementations, such as that provided by 2 independent VMs, and the emphasis is mine. Generally, this is talking about the kind of risks a proposal might have. So with something that's really large and syntactic, like async await, we know that that's not going to break the web because it's syntax. But we don't actually know for sure if browsers are going to be able to implement this in a performant way. And stage 3 is kind of the time when we want to test that out. And so before we move into stage 4, we want to actually be able to kind of prove that it can be implemented. And then the other end of the spectrum is web compatibility. You may have heard of Smooshgate, the flatten and flat map method on arrays. Flatten turned out not to be web compatible because during stage 3, we discovered that MooTools, I think, had used it or something. It's always MooTools. And yeah, yeah, that's true. It is prototype sometimes. It's remnants of the days in the late 2000s when all of us thought it was cool to modify prototypes all over this place. So like essentially that's also the sort of thing that we want. We don't want to just ship on Chrome nightly or Chrome Canary and Firefox nightly and then put it in the language and then find out that it breaks a bunch of websites. So the reason it's hotly debated is because we can't really get everyone in the room to agree on a way to classify proposals, and no one really wants to see something rush in before it's ready. But also we don't want things to stall forever based on some arbitrary meaningless syntax. It doesn't really matter if exponentiation ships in 2 browsers because it's syntactic. It's not gonna break anything, and it's totally performant. There's no way to make it slow really. Slower than math.pow anyway. So there's currently 26 proposals that have landed in the language since ES 2015. I put the breakdown by year here. As you can see, most years it gets pretty big. In 2020, which comes out next June, there's already almost 3 proposals that are stage 4. So some examples are async await, which I mentioned earlier, object.values and object.entries, object rest and spread syntax, promise finally, array flat and flat map, which I mentioned, dynamic import, and then big int is the kind of half there because they still have some pull request issues to work out. But as soon as that's done, it'll be stage 4 and in the language. And as you can imagine, some of these proposals took a long time to go through the process, and some of them went through rather quickly. Kind of depended on the size of the proposal, the risks involved, and how intuitive or kind of obvious they seem to be to the group of people in the room. So when I mentioned all these risks, I kind of talked about characteristics of proposals. So if it's got new APIs, so like a method name or a global of some kind, a constructor. So the questions I would try to ask to think about how to classify a proposal are, does it add new capabilities to the language? Something that you couldn't do before. New helpers, like a way you can do it, but it's really easy to screw it up, or it's really like annoying to type out all the code to do it right. And this way the language does it right for you. New primitives, and when I say that, I don't mean like string and Boolean, I mean like promise is a new primitive. So it's like a new kind of core concept to the language. And then if there's web compatibility risk, like pretty much anything on a prototype has web compatibility risk, and many things that create new globals have web compatibility risk. And then of course you ask kind of similar questions about new syntax. One of the important ones is expectations from other languages and like intuition. So like if you look at this syntax, what are you going to think it does? And that's going to be largely informed by what other languages you spent a ton of time with. And then also the last one is, how does it reduce the rapidly shrinking design space? So like we're almost out of single character tokens to use for new features, which means that additional proposals that have syntax may have to find creative ways of adding new keywords that are web compatible and don't create kind of a symbol soup of like, well, this is, the at means one thing, but at hash caret means something, like nobody would want that language. So that's kind of a, as we add more proposals to the language, that's a big consideration about syntax. So please get involved. There's a lot of work involved. Most of us on the committee, our full-time job is not doing standards work. Most of us are doing it in our kind of spare time. Like our managers give us our 6 weeks a year, but like that's it. And there's only a few people whose full-time job is standards work. There's lots of ways to help. You can contribute documentation. You can add tests. You can provide just your feedback, even your opinion. Even if you think something is ugly and you hate it, like that may not cause anything to change, but it's still useful to hear that people feel that way. Because we're not trying to make crappy things that no one likes. It's just sometimes there's a lot of competing constraints, and getting involved in the conversation might help you understand those constraints, but it also might help us understand those constraints better, and that helps make a language better for everyone. So thank you. That's me on Twitter. You can check the proposals list. And then that link down at the bottom there is the link to the slides. It's just a bit.ly link, but I like the shorter one. So please check them out and ask me if you have any questions through any mechanism.